Alright, so we're problem solving. So here's our first problem. And again, we want to read through quickly the first time. Two wires are parts of the supports of a pole. One wire forms an angle of 53 degrees with the ground, and the other wire forms an angle of 78 degrees with the ground. The distance between the wires on the ground is 25 meters. Find the height of the pole to the nearest tenth of a meter. Alright, we got a story. We got poles, we got wires, we got angles. Big idea. Okay, now we're going to read again. Two wires are parts of the supports of a pole. One wire forms an angle of 53 degrees with the ground. Now, we're given a picture. If we weren't given it, we would start to sketch our own. Now, on a sheet of notebook paper or graph paper, let's go ahead and draw this diagram. So we have the pole, and we have this one wire, and that first sentence says that this wire is forming an angle of 53 degrees with the ground. Wire, ground, 53 degree angle. Alright, go back to reading. The other wire forms an angle of 78 degrees with the ground. Again, we've got the drawing here, but if we didn't have it, we should actually be able to draw this on our own, because we have another angle here, another wire, and this angle is 78 degrees. The distance between the wires on the ground is 25 meters. So you look here, this 25, notice this 25 is going from wire to wire. The 25 is not going to the pole, right? Wire to wire is 25 meters. Not going over here to the pole. Find the height of the pole to the nearest tenth of a meter. We want to find the height of the pole. This is what we want to find, the height of the pole. I'm going to mark that as X. I'm also going to take a highlighter. This is what I'm looking for. Okay? Because sometimes students do lots of great math, but they don't answer the question that's being asked. Always identify what it is you need to know. Alright, next, we're going to make a little table. What are the things we know? What is it that we need to know? And I like to start with what we need to know. We need to know X, which is the height of the pole. And guys, when you make your little T-chart, you don't have to write in complete sentences. This is like notes for yourself. It's kind of like a brainstorming thing. What do we know? Well, we know 53 degrees, 78 degrees, 25 meters, right? We've got those three pieces of information. So, in addition to all that, do you see in our diagram, can you see the three different triangles? Right? Here's a triangle with the two wires. Here's a triangle with a wire and a pole, and then here's a big triangle with the other wire and the pole. I know I've got 53 degrees, 78 degrees. I know one other angle. Do you know what other angle we know? 90 degrees, right? The pole and the ground are perpendicular. So I also know there's a 90 degree angle. That's something else I know there. Do I currently have enough information to find X just in one step? Right? If I look at this triangle, like, here's a right triangle, but can I do the Pythagorean theorem? Not enough information, right? If I look at the big triangle, do I have enough for Pythagorean theorem? No. Can I remember to do law of sines? I need to know an angle and the side across from it. I don't have enough information on my picture right now to do anything. Okay? So there's got to be some other stuff I know where I can get there. What are some other facts that you know about triangles?
They all convert to 180 degrees.
All right, so triangles add up to 180 degrees, right? You know that. Can that help us get some more information? So what else can we know? If this is 90 and this is 78, how much is this angle right here? 12 degrees. All right, that's probably going to be helpful. What else can we know? If this is 53 and this is 90, can we figure out this angle here? That would have to be 37. So that's 37 going all the way across. So now can we find this little angle? 37 subtract 12. So is this little angle 25 degrees? All right. Oh, now look inside this triangle. If you know 53 and 25, can you find this angle right here? Figure out what this angle is for me. Oswaldo? 102 degrees. Now, some other people might have found this 102. Do you know that these two angles right here form a straight angle? They are supplementary, or they're called a linear pair. And those add up to 180 degrees. Do you remember that from geometry? So some people might have found that 102 a different way. All right, now we have a lot more information, right? There's a lot more that we know. Is there a way for us to get to X yet? No, not yet, right? I need another side. Well, is there a way for me to know this guy? Let's look just in this triangle. Do you know an angle and the side across from it? And do you know another angle? And then you could just be missing this side. Let's call this green side H. I'm going to call it that for hypotenuse. Can you now set up the law of sines? All right. Go ahead on your paper and how would you set up the law of sines for H? All right. You ready to take the test? This is the one with the arc length and everything. All right, we know that the sine of 25 degrees is here over 25, right? And again, for some of you seeing this, so here's my 25 degree angle, and across from it is my 25 meters, right? And then that would be equal to the sine of H, the sine of 102 degrees over H, because this is my 102 degrees and H is across from there. All right? So now go ahead and solve for H. All right, so we're going to come do our cross product. H times the sine of 25 degrees equals 25 times the sine of 102 degrees. I'm going to divide both sides by sine of 25 degrees. Sine 25 divided by sine 25 is 1. H times 1 is H. Once you have the variable by itself, it's time to use your calculator. Make sure your calculator is in degree mode. All right, can somebody read me the answer that they got? 57.86. All right, now here's something very important. When I go back to my question, it says round to the nearest tenth of a meter. So at the very end of my problem, I'm going to round to the nearest tenth. I want to carry things out at least to the 10th, maybe even one more space. Like, don't round this off to 58, okay? You have to keep your precision along the way. All right, so now if I know what H is, now can I find X? All right, let's look at my big triangle. Let's look at this big triangle. Can you do law of sines with your big triangle? Sine 90 over H, sine 53 over X. That would work, right? Actually, there's a shorter way. Is this a right triangle? Right triangle? SOHCAHTOA works on right triangles, right? Trig ratios work on right triangles. Let's use our 53 degrees. This is my opposite. This is my hypotenuse. Sine has opposite over hypotenuse. So I can say sine of 53 degrees equals X over 57.86. See how I set that up? All right, multiply by 57.86. These divide to 1. X is by itself. Type in your calculator. All right, going back to my word problem, it says nearest tenth of a meter. So what would our answer be? 46.2. Now we are going to answer in a complete sentence. The question said, find the height of the pole to the nearest tenth of a meter. The height of the pole is 46.2 meters.